Hello there, ladies and gents. We are ready to wrap a unit circle, and we're going to talk. I know we just did a lot of pi stuff because that's how the circle is kind of thought about. A circumference is 2 pi, and pi, is the ratio of diameter and circumference. So we're going to look at a circle, but we're going to talk about it in degrees, which might be more comfortable for you. But be aware, you do certainly want to know those pi things, and we're going to talk about what those pi things really mean in a couple videos from here. But we're going to look at this as a wrap of 90 degrees. And if you think about it, when we just did the last derivation of the unit circle, we talked about how we split 90 degrees into thirds. So we got pi over 2 reduced down to pi over 6 when we're talking about distance. Okay, so now we're not necessarily talking about distance, right? 90 degrees is not a distance. 90 degrees is a rotation. Okay, so we're going to rotate 90 degrees. And what we're going to rotate is what's called an initial ray. I'm going to have a ray right here. Boom, there's a ray. And I'm going to rotate that ray 90 degrees. So it ends right here. So I went from an initial side, to the ending side, which is the terminal side. Anybody ever watched the movie The Terminal? Crickets, huh? No response here. Okay, anyway. Terminal. I'm not sure if I recommend it or not. It was an interesting movie. Tom Hanks, I believe. Not his best work. Anyway, terminal side there. Initial and terminal, we have the rotation going right here. 90 degrees puts us at, obviously, the coordinates 0, 1. 135 degrees. So now, 135 degrees, I'm starting here. I'm going to rotate 90 plus 45. Ding, 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 ding. Bells are going off. 45 degrees. We just did that. That's a special right triangle. 45, 45, 90. I remember we derived that to get the side lengths to be square root of 2. I remember square root of 2 over 2. I remember since I'm in the second quadrant, my x value is negative and my y value is positive. So I'm at negative root 2 over 2 and root 2 over 2. Running out a little bit of space here, so let me wrap of negative 540. 540 degrees. Whoa! That's like 360 and 180 combined in the negative direction. So negative 360, right? A full rotation is 360 degrees. But I'm going the negative direction, so I'm going to go like this. There's negative 360, and another 180 puts me at 540. So my terminal ray lies on the x-axis. Didn't we have a name for that? When it lies on the x-axis, what do you think? Nice work. You guys are on fire today. That is called quadrantal. And now you know why I said quadrantal angles before. A little bit of a Freudian slip. These are angles we're talking about. Rotations now at this point. We're changing these wraps from a bug crawling along the perimeter to a rotation. Something creating the shape by rotating around it. We can't do that when we're on boxy shapes, but when you're on circular shapes, rotation is a radius. So now we're going to start talking about rotations. So we're quadrantal, we're back over here. Coordinates are negative 1, 0. Let's just pick a couple more of these. Wrap of 30. A wrap of 30, we're simply just going to look at this guy and wrap 30 degrees right there. Create our terminal ray. That's our special right 30, 60, 90 triangle. So a wrap of 60 degrees gives us the coordinates of 1/2 and the square root of 3 over 2. How about a wrap of negative 120? Well, negative 120, go this direction. There's negative 90. I need 30 more. I need 30 more. Right? This is 30 degrees. That's 90 degrees. So the whole thing is 120. Well, that means this is 60 degrees. The distance from the closest x-axis is 60 degrees. I wonder why he said that so loud. The distance from the closest x-axis is 60 degrees. This is what we call a reference angle. A reference angle is the distance we are from the closest x-axis. The closest x-axis. My closest x-axis is the negative x-axis here, 60 degrees away. Why is that important? Well, we just did 30, 60, 90 triangles. I know the coordinates on a 30, 60, 90 triangle like the back of my hand. And I know the back of my hand well. All right, this distance right here is -1/2. Clearly not drawn to scale because I missed my 1/2 there. Okay, and this distance is -√3/2. The distances technically are positive, but why am I writing negatives? You got it, because I'm in the third quadrant. So my x value is -1/2. My y value is -√3/2. Okay, 60 degrees is my reference angle. Distance from closest x-axis. We will always refer to angles when we're trying angles that are greater than 90 or less than -90. We will always refer to them in terms of a reference angle. Okay, so look at, for example, a wrap of 330. 330 is almost a full wrap. We're not quite at 360, so I'm getting a little jumbled here, but here comes 330. There's 90, 180, 270, and 60 more puts me at 330. Well, 330 is 30 degrees short. 30 degrees short of a full revolution, a full period of 360 degrees. It's going to the exact same coordinates as 30 degrees did in the first quadrant. Okay, so this is going to be square root of 3/2. The one exception is my y value is negative because I'm in the fourth quadrant. Okay, these guys are reflections of each other. Very important to know. Wrap of 270 is equal to a wrap of what else? Well, 270 is the positive direction, 90, 180, 270 is right here. Wrap of 270 puts me right here. That's the same as a wrap of -90. It could also be the same as a wrap of 630. Okay, any combination of adding or subtracting 360 degrees. That is what we call a coterminal angle. Okay, two angles or more that share the same coordinate. And we talked about this in terms of Olympics. You know, somebody does a 360, somebody else does a 720. If you blink and miss what they did in the air, they look like they did the same thing, assuming they both land on their feet or their skis or snowboards or ice skates, whatever we're talking about here. Okay? It looks like they did the same thing, but if you didn't blink and you watched them in the air, the one guy rotated twice while the other person rotated once. That's different. Okay? So it looks the same in the end, but there's different stuff that happened in between. Okay? So we're checking out. We got coterminals here. We got reference angles. We talked about terminal sides. We talked about initial sides. Okay, a lot of good stuff going on here. We got first quadrant, if you don't remember, second quadrant, third quadrant, and fourth quadrant. All right, so there's a little bit talking about the unit circle and different angles. Have a good one.